Okay, so we've been given this question under calculus called integration. So we have to integrate this function with respect to x, and we've been given the limits. These are the limits that we've been given, 3 and 1. So this question is called the definite integrals. So you differentiate this with respect to x. The main reason why it's called the definite integrals because of the limits being given. If we had just something like this without these limits, then we had a constant here. It was supposed to be called the indefinite integral. So this one is called the definite integral. So how do you integrate this one? So let me just try to remind you with the formula that we have to use. So we have something like this one. I like using divide x as because it's calculus, which is equals to we're going to have x raised to power n plus 1 over n plus 1, okay, plus c. So this formula tells us to say, for example, we've been given, let me say, maybe 2x squared plus 4, okay, 2x squared plus 4. You have something like this. Then how do you integrate this? So using this formula tells you to say the powers that you've been given, you just keep on adding plus 1 to the power. So we have a power of 2 here, we just add plus 1. But for the constant, this one, it has to gain for that to which you are differentiating, you are integrating it to. For example, if you are integrating this with respect to x, it has to gain the variable of x. If you are integrating it with respect to maybe t, it has to gain that value of t. So what am I saying? This is what I'm saying. So 2x squared, if you integrate 2x squared, remember the formula says that just for the powers, you keep on adding plus 1. This is the coefficient of this variable, which is x, the a, okay, which is this 2 here. So now we are no longer interested in the coefficient of this variable. We are only interested in the powers. So let's keep on adding plus 1 to the power. So we are going to have something like 2x, 2 plus 1 over 2 plus 1 plus, this is the plus, which is here. The 4, this 4 here, it has to gain the variable in which we are integrating it to, and we are integrating it to x. We're integrating it with respect to x. So we are going to have a 4x. So you are going to have something like 2x. What is 2 plus 1? We are going to have a 3 over 3 plus 4x. Okay, so this one becomes the answer for the integration to this question here. So this is what we're going to be doing. Now, if someone asks you to say integrate the constant c, or integrate, let me say 0, if you want to integrate this 0, because under differentiation we say that each and every constant, when you differentiate the constant, for example, if you differentiate 4, it becomes 0. If you differentiate 4, it becomes 0. But if you integrate this 0, has to become what? 4, but it can't become 4. It has to become a constant, and 4 is the same constant. So when you integrate 0, the integral of 0 is constant c. The integral of 0, it's constant c. No wonder they do say that integration is the reverse process of differentiation. Okay, so let's get back to the question. Let me just try to erase this. We go back to the question. Okay, I'll read this formula for verification. Let me just try to erase it. Okay, so now this is our question, and we've been given the limits. Okay, so what are we supposed to do? Okay, let's keep the limits. Let's keep the limits. We have 3 and 1. I'll keep the limits outside. We have 3 and 1. So let's try to integrate this one. So 4x cubic, we just keep on adding plus 1 to the powers. So we're going to have 4x 3 plus 1 over 3 plus 1. Okay, minus 3x squared, we add plus 1 over 2 plus 1 plus remember we said that this constant here has to gain what? The variable from which you are integrating it to. In this case, we're integrating to with respect to x. So we are going to have our 2x here. So we have something like this. Then what next? We apply now the rules of algebra. We just add this. What is 3 plus 1? That's a 4. So we're going to have 4x raised to power 4 over 4 minus, what is 2 plus 1? That's a 3. So we're going to have 3x raised to power 3 over 3 plus 2x. Don't forget the limits of 3 and 1. So from here, what next? Now we start substituting. Where there is x for the first one, we substitute with 3. We go with 3. This is the upper limit, this is the lower limit. So we start first by the upper limit, then the answer we're going to get, we subtract it to the lower limit, then that will be our answer. So what I mean is, we are going to have, let me try to, let me try to simplify this. Okay, let me just try to simplify this expression. Let me just try to simplify. We have a 4 and a 4, so this and this can cancel. We're going to remain with x. 3 and 3 can go. We're going to remain with x. So here, our expression, we are going to have x raised to power 4 minus x raised to power 3 plus 2x with the limits 3 and 1. So now from here, that's when now start the thing of substitution. Where there is x, we substitute with the upper limits first. So we are going to have 3 raised to power 4 minus 3 raised to power 3 plus 2 open bracket 3. Okay. Then we subtract minus the lower limit. So the lower limit it's 1. So where there is x, we keep on substituting with 1. So we're going to have 1 raised to power 4 minus 1 raised to power 3 plus 2 open bracket 1. Okay. Yeah, so you have something like this. So now from here now we start multiplying. I mean, from here now we can punch this on the calculator. 3 raised to power 4 should be 81 minus 3 cubic, that's 27, plus 2 times 3, that is 6, minus 1 squared, 1 raised to power 4, that's 1, minus 1 raised to power 3, that's 1, plus 2. Okay, so what is 81 minus 27? So we have 27 and 81. Okay, 27, oh sorry, so we have 81 and 27. You can subtract like that. Yeah, so we're going to have a 7 here, 11, 7, 8, 9, 10, 11. You have a 4 here, 7, 8, 9, 10, 11. You have a 4 here, that's a 54. You have a 54 here. You have a 54. You have a 54 here, plus 6. Okay, minus 1 minus 1, that's 0, plus 2, okay, 2. Okay, so this one here, what is 54 plus 6? 54 plus 6, we're going to have what? 54 plus 6, that's a 60. 54 plus 6, we're going to have a 60 minus 2, which is equals to 58. So 58 becomes your final answer. So 58 becomes your final answer for this question. So this is how you solve the question with the integral. So this was our integral. Then we go to the next question. Let's try the next question, because there were two questions. The one, it was this one, and the for integration, and the other one, it was for simplification. Let's try to get another question. Okay, should be this one here. Okay, we have this question here. So this one we're supposed to simplify it in its lowest form. We were supposed to simplify this in its lowest form. So how do you simplify this question in its lowest form? Okay, so these are just fractions. If you just look at the question, these are just fractions. So if you have, let me give you an example of 1 over 2 plus 1 over 2. You know that these are halves. A half plus half is equals to 1. But how do you solve this? So the common denominator here is 2. The number where 2 and 2 can go without leaving a remainder. The lowest common multiple of 2 and 2 is 2. So we're going to have this 2 into 2, 1. 1 times 1, 1. Plus, we do the same 2 into 2, 1. 1 times 1, 1. What is 1 plus 1? That's a 2 over 2. So 2 into 2, 2 into 2, that's 1. Wonder you, if you add half plus half, you're going to have a 1. This is what we are going to do here as well. So we have 1 over x minus 1 minus 10 over 2x plus 1. Others from here, they just do a cross multiplication. Yeah, which is okay, but I would rather go step by step. Okay, so the first thing that we have to do, let's try to find the common denominator for 2x plus 1 and x minus 1. So what we do, we can get just this and put them as in our common denominator, x minus 1 and 2x plus 1. Okay, so from here we start now dividing x minus 1 into x minus 1. These cancels, we remain with 2x plus 1. 2x plus 1, when you multiply with 1, you are going to have 2x plus 1 minus 2x plus 1 into 2x plus 1. This cancel goes, you're going to remain with x minus 1. So x minus 1 times 10, let's write our 10 here because so that we can multiply it nicely. So we're going to have x minus 1 equals, okay, so from here we keep our 2x plus 1 because we've already multiplied it with the 1 there. Okay, minus, what is 10 times x? We're going to have 10x. What is negative 10 times negative 1? We're going to have a positive 10 here. Then over x minus 1 to x plus 1. Don't forget your denominator. Okay, so from there, what next? We try to collect like terms. So we're going to have 2x minus 10x plus 1 plus 10, okay, over our denominator, which is x minus 1 to x plus 1. This is a 1, okay. So now here, what is 2x minus 10x? 2x minus 10x becomes what? Negative, because we're subtracting the what's this? But there's the lowest number is being subtracted. The bigger number is being subtracted from the lowest number, so the answer is always negative. So 2x minus 10x, we're going to have negative 8x. What is 1 plus 10? That's 11 over over, don't forget our denominator, x minus 1 to x plus 1. To x plus 1. So we are going to have this as our lowest, being simplified into its lowest form. Into its lowest form, you can have this. So this one becomes your final answer.